Alright, so in this video, I'm going to be solving the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So let me first rewrite my equation down here so I have a little more solving space. So my equation is 3 to the power of x plus 3 to the power of x is equal to 12. And the first thing I'm going to do from here is factor out 3 to the power of x from my left-hand side. So I get 3 to the power of x times, 3 to the power of x divided by 3 to the power of x is 1. So 1 plus 1 is equal to 12. And 1 plus 1 is 2. So I get 3 to the power of x times 2 is equal to 12. And now I can divide both sides by 2. So then these two cancel out. And I get 3 to the power of x is equal to 6. Now from here, what I'm going to do is take the log on both sides. So I get log 3 to the power of x is equal to log 6. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 3 to the power of x, so I can move x to the front. So this turns into x times log 3 is equal to log 6. Now from here, I can divide both sides by log 3. So then these two cancel out, and I get x is equal to log 6 over log 3. Now, log 6 is the same thing as log of 3 times 2. And if I have something in the form log a times b, this is equal to log a plus log b. So log 3 times 2 turns into log 3 plus log 2, and I have this over log 3. So now this turns into log 3 over log 3 plus log 2 over log 3. So then these two cancel out, and I get 1 plus log 2 over log 3. So this is my answer. Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now, 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000, so I get 1000 squared plus 23 times 1000, and now I can distribute 25, so I get 25 times 1000 plus 25 times 23. Now 1000 squared is equal to 1 million, so I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem.